Hello everyone, we are from Group 4 and today we would like to present about a project for subject BEE 32402 numerical method. So our group members are Daniel Ashraf bin Syarul Anwar, Muhammad Amir Irfan bin Roslan, Emerson Anak Saleh and me Muhammad Hadri bin Hussein Chi. I will begin with the introduction. So differentiation is defined as a rate of change. So as you know that rate of change is mostly used in our lives like velocity, acceleration, and in the graph they will show a graph of a curve graph. So in the cases where a function is not easily differentiated analytically or a set of data is given, numerical differentiation can be used to estimate this data. This data does not involve a need of knowing the actual equation of the rate of change and can be estimated by using data from graphs only. And that is what we will do today.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amin Ifami Roslan. My matrix number is CE210021. Today I want to explain about question project and manual calculation. So for the question project is we get from Google Scholar. This is our data and this is the table of the data. So from this we choose to make a Taylor series. So from that this is our manual calculation that we have made. First of all, we need to build up the table like this. Include x1, 1, 2, 3, 4, 5, and fi. This data refer from this. So from that, we need to find the value of 2-point backward difference by using this formula fx plus h minus fx divided by h. So fx is this and y for the fx is this. So from that we take the value and put into the formula. So meanwhile for the 2-point backward difference, the formula is fx minus with fx minus h. So this is the data we take and this fx. So for the third 3-point center difference, so this is the formula fx plus h minus fx minus h divided by h. So fx this data minus with this data and divide by h. So for the h is equal to 1. So next 3-point forward difference is this is the formula. Same, we took the data from this and put for the formula equation, and this is the answer. Repeat until the 5-point difference formula, and the last one is 3 points, and the next is 3-point central difference second derivative. This is the formula from second derivative. This is the formula and the data we take from this, and the answer is this. So the last one is 5-point difference for the second derivative. This is the formula and all divided by 12h square power of 2. So the data we took from this table and put into the formula this. So from that, this is the manual calculation part. Thank you.
Hello, I'm from Group 4. This is the project for numerical method BEE 32402. And my name is Emerson Anak Saleh and my metric number is CE21029. And this is my 3 other group members. So I will do the methodology of the project. Okay, in this project, we must define a problem in the outside of our book. So we need to find some article, and if there's some problem, we must taught the lecture first before we proceed to the MATLAB and the manual calculation. So firstly, we must make some research for the problem on the internet. and then we need to record and documentation it in the project. So the method that we have been used were first derivative using Taylor series, and then we uh, need to using a MATLAB software because we need to compare between the manual calculation and the software. And this is number one is 2.4 differentiation. So this is the how to find it. And this is a 2 point backward differentiation. And this is the how we find it. And this is the formula for each what for each point that we want to get in the project. Okay, that's all for me. Thank you.
Hello, my name is Daniel Ashraf. I will present the simulation part for this project. This simulation is to prove the answer is correct for the manual calculation. So, as we can see here, I already insert the formula and calculation in this software. So, for the first equation for first derivative is f fx plus h minus fx divided by h for the first equation. So when we want to see the answer is correct, we need to run the simulation. So the step size for this question is the 1. So we need to enter the number 1. So it will appear which derivative you want to compute. So we need to put the number 1 for the first derivative. So as we can see here, this is the answer that we get from the simulation. So for from comparing the from comparing with the manual calculation, the answer for the first 2-point forward difference is 0.1100. So as we can see here, the answer is the same as the manual calculation. Next for second derivative, we need to run the simulation again. We need to enter the step size, choose the second derivative by inserting number 2, and we can see here the answer is negative 0.0200. So for second derivative manual calculation, we can see the answer is the same as the simulation. So for the conclusion for this simulation is we can calculate the calculation for numerical differential in MATLAB simulation. So that's all from me. Thank you.
So in conclusion, the rate of change of the spindle speed used for a friction welding for a 4 mm plate is successfully estimated using the second derivative method and also Taylor series method. Um, the calculated values were the same as the value that we obtained using MATLAB. We were able to estimate the values just by using data of the table without any usage of a mathematical equation, which is very useful in real-world application as data recorded in experiments are usually not followed with specific equations early on, and the equations are only made up or obtained later on in the experiments. So this uh, estimation method will allow quick analysis of the obtained data without having to find out the actual equation first. And that is all from us. Thank you.